As Benjamin Franklin once said, "You may delay, but time will not." Time, a concept so intriguing and fascinating that it has captivated the minds of philosophers, scientists, and poets alike. It's a term we all use, but what does it truly mean? In different languages and cultures, time has been assigned various synonyms, same, kal, wakt, among others. These words, although different in their phonetics, all point towards the same enigma that is time. But these are just labels, names we have given to this unseen, unfelt, yet all-encompassing entity. We know it exists, and yet we can't touch it, can't see it. So, what exactly is time? Is it the ticking of the clock on your wall, or the changing of the seasons? Is it the aging of your body, or the memories that fade in your mind? Is it the sun rising and setting, or the moon waxing and waning? We feel time passing, we see its effects, but we can't grasp its essence. In the realm of physics, time takes on a more tangible form. It becomes a fundamental unit, a standard by which we measure and quantify everything around us. It's a dimension, the fourth one, that defines the position of an object in space, along with its length, width, and height. But does that define time in its entirety? Then there's the concept of relativity. We've set Greenwich Mean Time as a standard, dividing the world into time zones for our convenience. But isn't time supposed to be universal? Why then does it change as we move across the globe? Some philosophers argue that time is indefinite and unidirectional, always moving forward, never backward. It's a progression, a flow that started at a point unknown, heading towards an end that's equally mysterious. We've tried to tame this wild river of time by breaking it into smaller units, years, months, weeks, days, hours, minutes, seconds, and even smaller fractions. So what exactly is the time? Let's delve into this enigma. In the world of physics, time holds a unique position. Indeed, it's not just a simple ticking clock or a flip of the calendar page. It's a fundamental unit, akin to length and weight, playing a pivotal role in the realm of physics. Let's delve into this a bit further. Imagine a world without time. How would we measure the speed of a car, or the duration of an event, or even the period of a pendulum's swing? It's time that allows us to quantify these things. By providing a unit of measurement, time enables us to ascertain the duration of events and the intervals between them. It's as fundamental to our understanding of the universe as measuring how long or heavy something is. But time's role in physics doesn't stop there. It steps up the game by being more than just a fundamental unit. It steps into the realm of dimensions. Yes, you heard it right, dimensions. In the world of spatial physics, time is considered the fourth dimension. Now, you might be thinking of dimensions in terms of length, width, and height, the three dimensions we encounter in our daily lives. But let's add another layer to this. Just as an object's position in space can be described by three spatial dimensions, the fourth dimension, time, helps us locate an object not just in space but in time. Consider this. If you want to meet a friend, you need to know where. That's your three spatial dimensions, but also when, that's time. So, in spatial physics, an event or an object is defined by its position in space and time, often represented as x, y, z, t. So time is not just a concept, it's a dimension, a fundamental unit. It's a fascinating player in the grand stage of physics, a unit that measures, a dimension that locates, and a concept that continues to intrigue us. And as we go forward, or should I say as time goes forward, our understanding of this elusive entity continues to evolve. Did you know that time is relative? Yes, you heard it right. Our perception of time is not absolute, but rather, it's influenced by our position in space. To understand this better, let's consider the concept of Greenwich Mean Time, often abbreviated as GMT. GMT is a term that was formerly used to denote solar time at the Royal Observatory, located in Greenwich, London. In the present day, it has been replaced by Coordinated Universal Time, or UTC. Yet the term GMT persists in common usage. It's considered the world's time standard, the benchmark by which we measure time across the globe. Now imagine a world without such a standard. Different regions would follow their own local solar time, leading to a chaotic cacophony of clocks. A midday in New York might coincide with midnight in Beijing. To avoid this confusion, we've neatly divided the world into 24 different time zones, each representing 1 hour of the day. These time zones are based on the Earth's rotation and our position relative to the Sun. When it's noon in the GMT zone, the Sun is at its highest point in the sky. As we move east or west from this point, the local time changes. For every 15 degrees of longitude we cross, the time shifts by an hour. What's fascinating is that our perception of time is based on these standardized measures. For someone in New York, the day starts when it might be ending for someone in Tokyo. So in a sense, our experience of time is intimately tied to our geographical location. This relativity of time is not just a curious quirk of our global society, but a fundamental aspect of how we organize our lives, plan our activities, and even perceive reality itself. So, the next time you glance at your watch or phone to check the time, remember that this simple act connects you to a complex, global system of timekeeping that spans our entire planet. Our understanding of time, then, is tightly tied to our location on Earth. Some philosophers view time as an indefinite, unidirectional progression. This perspective, albeit abstract, lends itself to a profound understanding of time's enigmatic nature. Time, in this philosophical lens, is not a finite entity, but an endless journey, forever moving in one direction, forward. This concept of time's indefinite progression stirs the mind to ponder the genesis of time itself. The question arises, when did time begin? What was the genesis point of this ceaseless one-way journey? The truth is, we don't know. Time's origins remain shrouded in mystery, a question mark that has yet to be resolved in the annals of human knowledge. It's as if time has always been there, a silent, constant companion to existence itself. And yet the enigma doesn't stop at the beginning. The progression of time also begs the question, what is it marching towards? Is there a destination, an endpoint to this journey? Or is time simply an eternal traveler, journeying through the cosmos without a final destination? Again, the answer eludes us, as it has for centuries. The philosophers who consider time as an indefinite progression suggest that time, in its essence, is an eternal journey without a beginning or an end. For many, this viewpoint can feel overwhelming. The idea of a phenomenon so integral to our lives being so indefinite and ungraspable can be disconcerting. However, it's this very mystery that makes the study of time so fascinating. It's an enigma that continues to challenge our understanding, push our boundaries, and inspire our curiosity. The indefinite progression of time is a testament to the boundless nature of the universe and our quest to understand it. It challenges our preconceived notions, urging us to think beyond the confines of our conventional understanding. It reminds us that there are mysteries in this universe that are yet to be unraveled, secrets yet to be discovered. In this view, time is a mystery we continue to unravel. As we delve deeper into the mysteries of time, we continue our journey towards understanding this indefinite, unidirectional progression that shapes our existence. Opening. For our convenience, we've broken time down into various units. In our quest to understand and make sense of the world around us, we've taken the vast, immeasurable expanse of time and compartmentalized it into digestible chunks. We've created a system, a structure, that allows us to map out our existence in a way that our minds can comprehend. Let's start with the larger units of time. We talk about ages and centuries, immense periods that help us chart the course of civilizations and the progression of human history. They give us a grand perspective, a bird's-eye view of the passage of time. Then we move to smaller units, decades and years. These are our personal landmarks. They mark the stages of our lives, our growth, our evolution. We celebrate them, we mourn them, but always we measure ourselves by them. Months and weeks give us a more immediate sense of time. They structure our routines, our habits. They tell us when to sow and when to harvest, when to work and when to rest. Days, hours, minutes and seconds, these are the units of our everyday lives. They are the heartbeat, the rhythm of our existence. We plan our lives around them, from the mundane tasks of daily living to the moments that define us. Then we delve into the world of the microscopic. Microseconds and nanoseconds, these are the realms of the scientific, the technological. They measure the speed of computers, the flicker of light, the minutest phenomena that our human senses can't detect. All these units, from the grand to the minute, are our attempts to harness time, to give it shape and form, to make it tangible. Every tick and tock, every flip of the calendar page, every swing of the pendulum is a testament to our need to understand, to measure, to control. Closing. And it is this division, this measurement, to which we refer as time.